the distance and midpoint formulas. So a coordinate system. So first, take a line, draw it on the plane. So any line, just draw it on the plane. We'll call that line the x line or x-axis. Next, draw another line in the plane that is neither parallel nor coincident with the original line. We'll call that line the y line or y-axis. The point of intersection, since they are neither coincident, meaning the same line, nor parallel, meaning that they don't intersect, then they intersect at one point, and we'll call that one point of intersection between these two lines the origin. These two lines partition the plane into four regions: the first, second, third, and fourth quadrant. I can associate with every point in the plane a ordered pair as follows. Suppose I have some point in the plane. Let me take a line parallel to the y-axis, passing through the point. Find where that line passing through the point parallel to the y-axis intersects the x-axis. Measure the distance from the origin to that point of intersection. If we are to the right, if this point of intersection is to the right of the y line, I'll call this positive. And if it's to the left, I'll denote it as negative. So I can associate with this point the value x being either the absolute value or the negative absolute value of the distance between that point of intersection and the origin. Next, I can associate this point with another number. Take a line passing through this point parallel to the x-axis. Find where this line intersects the y-axis. Measure the distance from this point of intersection to the origin. Let's say that this is y. If it's above the x-axis, I'll make it positive, below the x-axis negative. So I can associate with the point P the two numbers, x and y. I'll call x the ordinate and y the abscissa. Well, we used to call them that. We stopped calling them that. We called them instead, well, instead of ordinates, we called them, well, an x coordinate and a y coordinate. And eventually we actually got rid of these used to be two words, co and an ordinate, but we made into one word, the coordinate. So this construction is called the Cartesian coordinate system. This is named after René Descartes. René Descartes was a very famous philosopher, mathematician, religious, he wrote things in religion, philosophy, mathematics. He was notoriously lazy, and so he would sleep till like 2, 3 in the afternoon. And so one afternoon, when in bed, he noticed a fly, buzzing around, and he said, "Well, I can put a coordinate system to that path." And so this framework here is called the Cartesian coordinate system, named after Descartes. Descartes in Latin is Cartesian, and so it's called the Cartesian coordinate system, named after him. If at the point of intersection, of the X and Y axis, these intersect at a right angle, we will call this a rectangular coordinate system. We'll always be assuming in this class that we're dealing with rectangular coordinate systems. The Pythagorean theorem. So suppose I suppose I have that a squared plus b squared equals c squared. This is true if and only if this triangle is a right triangle with whose hypotenuse has length c and whose legs have lengths a and b. The hypotenuse is the side opposite the right angle. And so a squared plus b squared equals c squared if and only if this is a right triangle, where c here is the length of the hypotenuse. So let's look at the distance first on a number line. So suppose you have the numbers 8 and 3. What's the distance from 8 to 3? Well, 5. How did you do that? Well, you just did 8 minus 3 is 5. So the distance is just equal to, well, I don't know which one is bigger, A or B. And so it's just B minus A, but I'll put a little absolute value since I don't know if A is bigger than B or B is bigger than A or vice versa. Okay, so the absolute value. I wrote the absolute value here, so maybe I should tell you what it is. The absolute value is the distance from the point X to the origin. It is the magnitude of X. It is the square root of X squared. It is equal to X if X is non-negative, and it's equal to negative X if X is negative, so that its value is never negative. It is the positive part of your number. So the absolute value of negative 12 is 12. The way I have written the absolute value in this form is called a piecewise defined function. Okay. A distance in the plane. So suppose I have 2 points in the plane, P and Q. Then the distance between P and Q, I'll denote that by D, can be determined just using Pythagorean's theorem. A squared plus B squared equals C squared. Where, well, A is the length of this side of the right triangle. I'm assuming this is a rectangular coordinate system. So where A is the length of this side of the right triangle, B is the length of this side of the right triangle, and C is the distance D that we want to determine. Well, the distance from x1 to x2 is just x2 minus x1 in absolute value. We already did that above. And the distance from y1 to y2 is just y2 minus y1 in absolute value. Therefore, a squared plus b squared equaling d squared, equaling c squared just says that d squared is, well, x2 minus x1 quantity squared. The square, if you square something that has absolute value, it doesn't really matter because the square is always going to be positive, non-negative. So I don't have to write the absolute value. Plus, well, b squared, so y2 minus y1 squared. So to figure out d, I just take the square root of both sides of my equation. So the distance from the point P to Q is just the square root of the sum of the squares of the differences of their coordinates. The midpoint. So if you suppose you have 2 points, 7 and 5, and I want to find, well, what's the midpoint between 7 and 5? What's the average of 7 and 5? Well, I just add them. 5 plus 7 is 12, and divided by 2 is 6. So the average of 5 and 7 is 6. The midpoint between the points 5 and 7 on the number line is just the number 6. Let's do the same thing in the plane. Well, if you take 2 points, P1, P having coordinates x1, y1, and Q having coordinates x2 and y2, and you want to find the midpoint between these 2 points, then you take the average of their x coordinates and the average of their y coordinates. So the midpoint is found by just adding x1 plus x2 divided by 2. That gives you the x coordinate. The y coordinate is given by y1 plus y2 divided by 2. So let's do some examples. Any questions about anything before I do some examples?
Can you hear me?
Okay.
Professor, can you hear me?
Professor?
Okay, so let me do problem number 23 on page 7. And so in problems 19 through 32, find the distance D between the points P1 and P2. Okay, so let's do that. So I have here the distance formula is just the square root of x2. Oops. Let me see what that is. Is this being recorded? The answer is yes.
Okay, yeah, that's what I'm trying to ask. So I just type in a chat
Yes.
box if it's being recorded. Thank you.
All lectures are recorded.
Okay,
And you can find the recording by, actually, if you go to the same place that you logged in to get here, one of the options is to view recordings.
Okay.
You can view the recording.
All right, thank you.
So it's the distance D is just the difference of the x coordinates squared plus the difference of the y coordinates squared. Now, it doesn't matter which one I call x1 and which one I call x2. I guess I'll call this one x1, y1, and I'll call this one x2, y2. Doesn't really matter which one I pick. Okay, so the distance D is the square root of x2 minus x1 squared plus y2 minus y1 squared. Subtracting -4 is the same as adding 4. And so I have that the distance D is equal to the square root of 5 minus 3 is 2. 4 plus 4 is 8. Obviously, that's a little longer than I need. So the distance here is equal to 4 plus 64. So the square root is 68. But I can actually simplify that a little bit. I can write 68 as 4 times 17. And so the square root of 4 is 2. Oops. And the square root of 17, well, you can't really simplify it any further. So it's 2 rad 17. In general, on exams, I will want you to write the exact answer. You may also want to give a calculator answer, but in general, I want the exact answer. You can put especially like on exams, you can just write in, an approximate answer. for your solution. It's much easier to write. You will not get full credit for unsimplified answers. So you will get partial credit. So if you only write, if it says, so in general, we always assume that you simplify your answers. So you will get partial credit on an exam for submitting a answer that is not fully simplified. Any questions about that? So you get partial credit at least. Okay. Let me do problem number 34. In problems 33 through 38, plot each point and form the triangle ABC. Show that the triangle is a right triangle. Find its area. Okay, so let's do that. So I guess let's plot each point first. I guess they want that. It's going to be a little hard to draw it here, but I'll try best I can. Let's see. 1, 2, 3, 4. There's no way. Okay, so maybe just because I'll start to do, I'll write something else here. So remember that to show that it's a right triangle, I want to use Pythagorean's theorem. So I wanted to show that a squared plus b squared equals c squared. And that means that ABC is a right triangle. Of course, to figure out each of those, I'll have to use the distance formula. Yeah, I guess I'll write it. Distance is x1. Who cares? I'll write it this way, just so that you note that it doesn't matter which way I write it. So, okay, so x1 minus x2 squared plus y1 minus y2 squared. Take the square root of that. Okay, so let me draw this. Now I have more room to draw. Okay, 1, 2, 3, 4. Okay, so I can do it there. These are big numbers, so got to make this kind of big. Okay, so this is, there's a 12, 13. So 2, 4, 6, 8, 10, 12, and a 3. 1, 2, 3. That's a 3 there. That's B. A was -2, so it's a -2, +5. So that's there. That's A. And C is 10. Oh, there's a 10. And then a -11. 2, 4, 6, 8, 10, 11. Oh, this is a big triangle. Okay. So that's C. Okay. Okay, let me try to rotate and see if I can do it better this way. There. 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 Okay, so somehow you want to see, is this a right triangle? Not 100% obvious from the drawing, Okay, so let's find the distance, let's say from the point O. Maybe I should actually label these points. So this is, B was 12, 3, C was 10, negative 11, A was negative 2, 5. Okay, so now let's find the distance between the points, let's say A and B. Okay, so let's take the square root. Actually, I'll write the square root at the end. So I'll just take the difference of their x coordinates, say 12 minus a negative 2 squared, plus, here again, it doesn't matter, 3 minus 5 squared. I'll take the square root of that. Okay, so this is equal to 14 squared plus negative 2 squared. 14 squared is 196. 2 squared is 4. And so this is going to be the square root of 200. I actually don't want to simplify this. The square root. So this is the square root of 200. In this case, it actually makes my life easier not to simplify. And you'll see in a second why. It's in order to use Pythagorean's theorem. Let's go from, I don't care, A to C. Okay, so let's go from A to C. So let's find that distance there. Again, it doesn't matter which one I pick to be the first one. Maybe I'll do X as 1 as being, I'll do 10 first. So 10 minus a negative 2 squared plus negative 11 minus 5 squared. Okay, so you just have 10 minus a negative 2 squared plus negative 11 minus 5 quantity squared. So this is going to equal 12 squared plus negative 16 squared. So I get here 144 plus 256 is 400. So that's equal to 400. And now let's look at this other distance. Hopefully that one's 200, radical 200. And so let's do the distance from B to C. And so I'll just do, oh, maybe I'll start with the 12. 12 minus 10 squared plus 3 minus negative 11 squared. And so this is 12 minus 10 squared plus negative 11 minus 3 squared. 12 minus 10 is 2, 14. These numbers look so familiar. So this is 4 plus 196 is 200. So I have here radical 200. And so now I want to see, is this a right triangle? Well, obviously the biggest number here is the radical 400. So that has to be your hypotenuse, the angle opposite the right angle. And so I just want to check, well, if I square radical 200, add it to the square of radical 200, 200 plus 200, is that equal to the square of radical 400? 400, sure. And so this will be a right triangle. Check if this is a right triangle. So let's do that. And so is a squared plus b squared equal to c squared? Is radical 200 squared plus radical 200 squared equal to radical 400 squared? Is 200 plus 200 equal to 400? Yes. So in this case, yes, this is a right triangle. Now I want to find the area of this triangle. So the area of a triangle is 1/2 base times height. Let me do this. So this area here is 1/2. Well, this is a right triangle. It's easy to figure out. So this is a right triangle. So this is the base, and this is the height. 1/2 of rad 200, the base, times rad 200, the height. And so in general, you should simplify these before it actually makes my life so much easier. Simplify. Rad 200 times rad 200 is 200 divided by 2 is 100. So the area of this triangle is 100 square units. Any questions about anything that I did? Okay. So, oh, I wonder if I do this and then move it up. Maybe that'll be better. Okay. In problems 39 through 46, find the midpoint of the line segment joining the points P1 and P2. So the midpoint is given by the following formula. So the midpoint between the point P1 and P2 is just x1 plus x2 divided by 2 y1 plus y2 divided by 2. And so let me call this x1, y1, x2, y2. So this is going to equal 2 plus 4 over 2, negative 3 plus 2 over 2. Okay. So this is equal to 6 over 2, negative 1 over 2. So my midpoint, okay, 1 second. So my midpoint is just 3 minus 1/2. So those are the coordinates of my midpoint. And that finishes off section 1.1. Let me go on to section 1.2. Any questions on section 1.1? Okay. Let me go on to section 1.2.